Okay, so welcome back. So today we're going to start talking about division of fractions. Okay, so let's start with the idea of dividing fractions or division in general. So now, as we know from previous discussions, that multiplication and addition are both what we call commutative, right? They have the commutative property. What does that mean? It means the order. We can switch things around. It doesn't matter how we multiply things, right? Or how we add things, right? We can do 3 plus 5 or 5 plus 3. We're going to get the same answer, 8. Or if we do 3 times 5 or 5 times 3, we're going to get the same answer, 15. So that's what the commutative property tells us. We can commute things, right? As I said before. Now, the commutative property does not work for subtraction and division. Okay? So we can't move things around like that. So now, again, I want to show just a couple of things, a little bit of review. So when we talk about 8 divided by, if we say 8 divided by 4, we can write it this way, or we can write it in a fraction, right? This is also the same as writing 8 over 4, right? So remember, if we write a fraction, it's the same as showing division, okay? Because this is the fractional bar represents division, 8 divided by 4, okay? So, just wanted to go over that. Now, what about if we want to divide by a fraction? We haven't covered that. So what about if I have 5 divided by 1/2? So again, remember, what does division mean? It's like, how many groups can I divide something into? For example, if I say here 8 divided by 4 or 8 divided by 4, I'm asking, hey, how many groups of 4 can I get from 8? And the answer is 2. Okay, if I divide everything evenly, right? Well, if I look at this one, 5 divided by 1/2, what I'm asking is, how many halves can I get out of 5? Well, how many halves can I get out of 5? If I divide, so how many groups that contain 1/2 can I get from 5? Okay, well, what if I do, so let's do that. Let's divide into the halves. Okay, well, I'm going to cut that in half, that into a half, that into a half, that into a half, and that one into a half. So if I count the number of halves, how many halves do I have, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there's the answer. So 5 divided by 1/2 is equal to 10. Now, I'm going to show you something about division of fractions. Okay, so I'm going to, well, let me show you. Okay, so if I want to divide fractions, they have to have the same denominator. Okay, there is a way to divide fractions, but they have to have a common denominator. Okay, so if I want to divide this, to prove that this equals 10, let's change this into a fraction. Okay, so I'm going to write this as 5 over 1 divided by 1/2. Now, I want to get a common denominator, so let's change this to a 2, since I can do that, right? So I can multiply, let's change this to a 2, so I'm going to multiply the top and the bottom by 2, so this will give me 10 over 2 divided by 1 over 2. So now, now that we've got a common denominator, now what we can do is we can we can divide across the top and divide across the bottom. And when we do that, what do we get? We get 10 divided by 1, and we get 2 divided by 2. Well, what's 10 divided by 10? 10 divided by 1? 10. What's 2 divided by 2? 1. And we get the same answer. So, we can divide fractions like we multiply fractions, because remember, in multiplying fractions, we multiply across the top and we multiply across the bottom. We can do that with division only if the denominators are the same. So, unlike multiplication, we can't just divide fractions anytime we want. They have to have a common denominator. So, is there a better way of doing that? Can we, is there a way that we can somehow maybe use another method that might be a little easier and we can get the same answer? Yes. Yes, there is. We can change it into a multiplication problem. Okay? How do we do that? Well, let me show you. So if I take 5 divided by half, and let's write it this way. I can write as 5 over 1 divided by 1/2. Okay, so what I can do is I can change this to a multiplication problem, but there's one thing I must always do. Okay, I must always flip the divisor. Okay, so this is equal to, right, 5 over 1 times 2 over 1. So I have to flip or take the reciprocal of the divisor. Okay, and again, if I multiply across the top, I get 10. But notice I get the exact same thing when I get the common denominator. Notice that when I multiply this by 2, I got 10 over 1 divided by 1 over 2, and I end up with the same answer when I divide the top and the bottom. Okay? And that always works. Okay. We'll do some examples and we'll continue on. Have a great day.